In this tutorial, we will be discussing the VSEPR theory and the 5 basic shapes that revolve around it. So let's review what VSEPR theory is. VSEPR stands for valence, shell, electron, pair, repulsion. So the electrons on the outermost shell of the atom are repelling each other as they make their shapes. And it's based on the number of electron groups attached to the center atom. Notice electron groups, so that includes lone pairs as electron groups. The arrangement of the atoms attached to the center atom minimizing the relative repulsion between the electron pairs. There's 5 basic geometric arrangements, or 5 different geometric families. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And we'll be discussing each one of these in greater detail. Linear is 2 electron groups attached to the center atom. Notice it does not matter if those are attached through single bonds or double bonds. It's still 180 degrees. So we're talking about groups of electrons here. In the future, we're going to see how it changes a little bit, but not dramatically. Trigonal planar, let's break that down. Trigonal, 3, tri. There's 3 things coming off of the center atom. So 3 things here as well. Planar, meaning that it's flat. They're in the same plane. So 3 electron groups attached to the center atom, with each electron group occupying the corner of a position on a triangle. So the 3 are in the shape of a triangle. Bond angle between these are approximately 120 degrees. If you notice at the one on the right, the carbon oxygen is a double bond. That makes a little bit more, because of those extra electrons there, it takes up a little bit more space in the single bond. It's a little more dense in electrons. So notice that this bond angle here and this bond angle here is a little bit bigger because it's trying to spread out. And subsequently, the one at the bottom is actually a little bit smaller. But they're still approximately 120. They're really close. Tetrahedral. Tetra means 4. So we're talking about something with 4 groups around the center atom. If we look over here, our Lewis structure then translates to this 3-dimensional shape. 4 electron groups surrounding the center atom, with electron groups occupying corner positions of a tetrahedron. The bond angle between the electron groups is 109.5 degrees. That's because they're trying to get as far away from each other as possible. When you look at the Lewis dot structure, it can be deceiving because it looks like it's 90 degrees here. But that's because it's flat, and it's not actually 90 degrees. Keep in mind that the Lewis dot structures have a really hard time with showing a 3-dimensional object. We're drawing something on a piece of paper that's flat. But in reality, atoms and molecules and objects are 3-dimensional, so we have to keep that in mind when we're looking at these compounds. The trigonal bipyramidal, if we break that down, trigonal is 3, tri, bipyramidal is 2, so 2 pyramids, so there's 5 total, and we'll look at that in a second, electron groups attached to the center atom. So the trigonal, the 3, there are 3 atoms at the equatorial level, meaning the equator. They're the ones coming out. If we look at, and there's 2 attached to the axial going up and down, if we look at that as a 3-dimension, you can see how it kind of forms a pyramid, which is right there. And so there's 2 pyramids. There's one on the top and one on the bottom, and that's where they get the name of bipyramidal. So trigonal, the 3 atoms, bipyramids being 2 pyramids. So there's 5 things coming off of it total. The bond angle between the equatorial positions is 120. So this is just like the trigonal planar from before, where they're trying to get it spread out as possible. However, the axial is 90 degrees. So this would be as if it's a straight line. Once again, it's trying to get as far away from each other as possible. The octahedral, which is the last one, has 6 groups coming off of it, and it's a little bit harder to visualize. So this is our original structure as a loose dot structure. This then translates over to a geometric structure such as this, where there's kind of a box, a square. And then this square then forms a pyramid. And that's where this is here. So octahedral, if we count the number of sides, there's 1, 2, 3 in the back, and 4 up here, sides to that pyramid. There's 4 sides on the bottom as well, so that adding up is where they get the name octahedral from. Is 8 sides. So there's 6 electron groups attached or surrounding the center atom. The electron groups in the shape of 2 square base pyramids are at base to base, with the central atom in the center of the shared bases. It is called octahedral because the geometric figure has 8 sides, and all positions are equivalent. The bond angle is 90 degrees. And that gives you a description of the 5 basic groups or families of the VSEPR theory. Now these families are then altered once the lone pairs are added in, and we'll be discussing those shortly in future tutorials.